Welcome back. We are on page 5 of the packet now, so average atomic mass. The first thing on here, so this might be a good idea to pause so you can fill it in. This is data that we collected last semester when we were all together in class. So if we are in class, this is something that just we'll take a collection of pennies, have students weigh them, and these are the masses of the pennies. But since I'm recording this video from home in the summer, this is just the data from last semester. When you're looking through this data, this was just 10 pennies that I took from a container that I had of pennies in my house. And when we weighed these 10 different pennies, we noticed that there was a pattern where most of the pennies seemed to weigh 2.5 grams, but there were a couple that were different. And I'm just going to go ahead and highlight the couple that were different, the ones that weren't 2.5. So that was this penny, and this penny. And so this is an example of looking at isotopes. They are all the same element, so to speak. In this case, they're all pennies, and yet they have different masses from each other. And just as a side note, if you look at those 3 pennies that are different, what you might notice about them is that the year that they were made was a lot different, a lot older than these other pennies. Old pennies used to be made out of pure copper. And then in the 1980s, I think 1982 or 1983, they changed the composition of pennies because copper is really expensive these days. And so the inside of pennies is actually made of zinc now. And so that changed the mass of the penny, even though the pennies from the outside look the same. From here, we have a couple of questions. And so this is something that you can work on. You just need a calculator. Let me grab mine. So the first thing is, what's the average mass of a penny? To calculate an average, we add up all the masses and then divide it by how many masses there were. So 2.5 plus 2.5, 2.5, 2.5, 3.1, just adding them all up down the line. Okay, so once I have all of those added up, I'm going to divide it by how many pennies there were. 10 pennies. And that gets us an average for our pennies of 2.67. Okay. Our next question on here is any penny this exact mass, 2.67? When we look down the list, we don't see any pennies that have that exact mass. All of our pennies are either 2.5 or 3.1, so we don't have any pennies that are exactly 2.67. And if we wanted to know what mass do most pennies seem to be, the most common number that we see over and over is 2.5. What we're really seeing here is that there's 2 isotopes of penny. Right? There's the penny that has a mass of 2.5, and there's the penny that has a mass of 3 or 3.1. And if we wanted to know which one of these 2 isotopes is more abundant, we have more of isotope 2.5, and that's why our average is closer to 2.5 than it is to 3. So this average is kind of our average atomic mass for pennies, the same way that we can do with atoms. With atoms, when we wanted to calculate the mass, the average atomic mass, we don't weigh each atom individually. We have percentages that tell us about the percentage of that mass element that exists in the world. So down here, for example, we have 3 different isotopes of sulfur with a mass of 32, 33, and 34, and we're given the percent abundance. Of all the sulfur in the world, 95% of it is mass 32, 0.75% has a mass of 33, and 4.21% of it has a mass of 34. So we can use this information to calculate what's called a weighted average. This is exactly how your GPA is calculated. This is exactly how your grades for your classes are calculated, where you have 70% coming from summative, 30% coming from formative. That's a weighted average. In order to calculate a weighted average, we have a couple of steps. The very first thing that we're going to do is take the percentages that we see over here, and we're going to convert them to decimal form. What that really means that we need to do is just take them and divide them by 100 so that it looks like a decimal instead of a percentage. So if I take 95 and I divide it by 100, we're going to move the decimal 2 times to the left. So 1, 2 would give us 0.9502. Going to do the same thing here. Move the decimal 2 times to the left. So this would be 0.0075. Move the decimal 2 times to the left, 0.4, and then one more time. So I need to add a 0 in front, 0.0421. Once we've changed those percentages into decimal form by dividing by 100, we're now going to take that number and we're going to multiply it by the mass. So we're going to multiply the mass by this decimal form of the percentage for each of the isotopes. So if I do that down below, taking that 0.9502 and I'm multiplying it by the mass of the isotope, which is 32. Okay, so same thing for the next one. That isotope had a mass of 33. And for the last one, I would multiply that 0.04 number by 34, since that's the mass of the isotope. What we're going to do next is we're just going to add up all of these pieces. So we're going to take this number and we're going to add it to this number. We're going to add it to this number, and I'm going to get my calculator answer. So I'm just going to go ahead and do this all in one step in my calculator. You can also do each individual step and then add them afterwards if you want, but I'm just going to make my calculator do all the math for me. So this plus the next piece plus the next piece. And here's my calculator answer for that. So 32.0853. All right. For how we're going to round these, we're going to keep 2 digits after the decimal. And we're going to round away the rest. And that's just so that we all end up with the same answer, and especially when you're doing Schoology assignments so that we all agree. Okay, so I'm going to keep these in front, and then 0, and then I need to just decide, should the last digit be an 8? After the 8 is a 5. A 5 or greater will make this number round up. So instead of this being 32.08, that 8's going to round up because of the 5, so 32.09 for this. The units that we use are abbreviated as AMU. AMU stands for atomic mass units. So not something that we're going to use much beyond this, because we never really weigh out a single atom. It's too small to see, it's too small to weigh. So AMUs aren't super useful for us in everyday life to talk about. Okay. I didn't fill in this one line. Add values together and then just round to get our final answer. So that's how we calculate average atomic masses. We go through those couple of steps, change the percentages into decimals by moving the decimal 2 over to the left, multiply it by the mass, and then add those up. At the bottom of the page, there's 3 more samples for you to try, and I will scan this that has the answers for you to check as well with those questions.